Okay, so this is a discussion on the definition of the derivative, and chapter 2 has been leading up to this. We kept big part was of that was taking the limits of different quotients. In fact, we saw that in some of the problems like that you see right here. We saw that we were looking at limits in the form of we had a function f of x, and then we wanted to look at the limit of f of f, the numerator is f of x plus h minus f of x all over h. And so that's just the slope of the line going from x to x plus h. And if we look at the limit as actually h goes to 0, we get what's called the instantaneous velocity, or the derivative of the function at some point x. Okay, so so the secant line is just defined of a function at a point x between x and x plus h is just defined as that quotient, and then the slope of what we're going to call the tangent line is actually the limit as h goes to 0. So yeah, so we'd be finding the slope of this line. I've got a better graph below. This grazes the line at x. So how are we going to get the slope of that straight line that intersects x comma f of x? This grazes the graph. So suppose the graph, here we see it's kind of accelerating, it's going up higher and higher, faster and faster rate. But suppose that at this point it just started moving in a straight line. Yeah, we want the slope of that line. Okay, so the slope. So finding that slope, right? Taking finding the limit of this quotient there as h goes to 0. So that's known as the instantaneous rate of change for f at x. In other words, let's just pretend that at this point the function all of a sudden started moving in a straight line. What would the slope of that line be? And there's all kinds of notation: f prime of x, dy dx, then this y prime of x, this y prime alone, and then this kind of the thing that kind of looks like a quotient right there. And so this is called the definition of a derivative. The limit of this difference quotient as h goes to 0. That's called the derivative of f of x. And this difference quotient is very important. So yeah, you see here, memorize, because there will be some problems. You'll be asked to calculate the derivative based on. We're going to learn rules for taking derivatives. So you're only going to be doing this for a small part of the course. But yeah, there are definitely problems. We're going to be asked to calculate a derivative just using that definition right there. So why don't we just look at a couple of problems right here. So of course, the easiest one is, sorry, before we continue, there's also some other ways of denoting the derivative. So the derivative at a specific point A, one way we could do it is just we look at this difference quotient right here. F of x minus f of a over x minus a. Let's take the limit as x goes to a. So again, yeah, you get 0 over 0. So if you're going to use that, if you're going to calculate the derivative from scratch, yeah, you're going to have to do some simplification, cancel out common factors. Hopefully they cancel out. Another way of calculating the derivative at a specific point A, and these two are equivalent to each other. F of a plus h minus f of a over h. So again, so this would be f of a plus h minus f of a over h. So that's just the slope of the tangent line going from a to a plus h. What happens is as h comes really very small. In any case, yes, you always need to compute a derivative. Yeah, you're going to need to compute a limit. So why don't we look at the easiest one of all, and that's always the slope of a straight line. Well, we actually know what the slope is, right? Even before looking at it, we're going to use the definition of the derivative to get the slope at any specific point. But we know ahead of time from algebra that the slope of the line is 3. So let's just use the definition. So the derivative of f of x, the derivative or the slope at any point x is given by, so again, the quotient is just the slope of the line going from x to x plus h, right? The rise over run. And again, so x plus h minus x, that's just h. That's why the denominator is h. And we take the limit as h goes to 0. So wherever we see x, we put x plus h. So 3x plus h minus 4 minus the quantity 3x minus 4. And then you expand and you simplify. 3x plus 3h minus 4 minus 3x. And be careful, because this is a common error in math. Distribute negative times that minus right there. We get plus 4. And you see almost everything cancels out except for 3h. And the only thing that doesn't cancel on the numerator is 3h. And then you divide that by h. Yeah, and so the slope is, at any point x, the slope is 3, right? Which kind of makes sense. We know that the, I guess that's 0 comma negative 4. Right, so the slope, no matter where you are, the slope is 3. For any value of x, the point, the slope is 3. So let's just do one more here. Okay, so and then we'll look at the graph. Okay, so let's say find the graph of the function f of x equals x squared minus 2x. I think it's always a good idea to graph if possible. Some of these functions might, the graph might just get so convoluted it doesn't help. But I did that on the next page. So there's the graph. So the curve. So x squared minus 2x. The graph is a parabola. So the blue is actually the parabola, and first of all we want to calculate the derivative, and then we want to know the slope of the tangent line at x equal to 3. So remember, the tangent line just grazes the graph of the function at x equal to 3, but it only intersects it at one point. Yeah. So the tangent line is what? So let's say all of a sudden the graph just said, okay, I'm going to start going at this constant velocity once I get to 3. I'm going to trace out that line that appears in red. Okay, so let's just see right here. Okay, so you want to find the slope of the function at any point f comma f of x. So once again, you want the slope at some given point x, or of the tangent line. So we're going to use the definition of the derivative. This is our friend right here. Right, the quotient is the quotient of the tangent line going from x to x plus h. And again, wherever you see x, you replace with x plus h. So it's x plus h quantity squared minus 2 times x plus h, then minus, and then just be careful, make sure you distribute this minus sign right here. That's a really, again, that's the kind of error that drives us crazy. And definitely you do a bad the distributions right is guaranteed to give you the wrong answer. Yeah, we don't want to get bad grades just because of distribution errors. So, okay, so you expand x squared plus 2x plus h squared, and then minus 2x, again, do that distribution, minus 2. So far, just from what I've seen, the distribution has been pretty good. Minus x squared plus 2x. And now simplify. Students, there better be a way of getting rid of the h's in all the terms. And let's say you get to here, and there's a term in the numerator that doesn't have an h in it. It's a good chance you made a mistake. Okay, so after you do all the canceling, like the terms without h, see x squared and x squared, they cancel. So all the terms that don't involve h should cancel. That's what I'm saying. If that happens, you simplify and there's terms that don't involve h in the numerator, well, it's a good chance you made a mistake. You see the minus 2x plus 2x. So what are we left with? 2xh plus h squared minus 2h. And now just cancel out. And students, I've seen a lot of problems with quotients here. Remember this h, right? You have to cancel h from every single term. Some of you are just canceling, going like h and, h, just canceling one h from one of the terms. So just remember that h divides all the terms. Okay, so you end up getting 2x, right? 2x over h is h. I mean, 2x h over h is 2x, right? H squared over h is h. Minus 2h over h is 2. And now you take the limit as h goes to 0, so that we know that, so at any given point x, the general slope is 2x. We have a formula. So f prime of x is equal to 2x minus 2. So we know the slope of the tangent line at any point x. We have a formula for it. Okay, so now it says find the slope of the tangent line at x equal to 3. So now let's just plug in, we're going to plug in. So we know that f prime of x, which is just the slope of the tangent line at any given point x, we plug x equal to 3 into 2x minus 2. And so what do you get? You get 6 minus 2 is 4. So we know that the slope is 4. And we know that, and the function is, what is our function? It's x squared minus 2x. You plug in 3, right? So you get 9 minus 2x, right? 9 minus 2 times 3 is just 3. So we know the graph goes through 3, 3. When x is 3, f of 3 is 3. Okay, and it goes to the let's find the equation of the line whose slope is 4 and goes through the point 3, 3. So we'll just use point slope form. Y minus 3, right? That's the rise, is equal to the slope 4. And again, that we've got that 4 just by plugging x equal to 3 into the general formula for the slope of the tangent line. And here's your run. So the equation of the tangent line is y minus 3 is equal to 4 times the quantity x minus 3, and then you put that into standard form, and you get y is equal to 4x minus 9, right? So we know that for any point x, the slope of the tangent line is 2x minus 2. Now let's get the equation. So at x equal to 3, we know the slope is 4, and now let's get the equation of the tangent line passing through 3 f of 3. Okay, we know the slope is 4, right? And so we just use just summarizing a point slope form, and then we put it in the standard form of it, right in the standard form of a line. And then you can actually do it for 2 other points or I'm just sorry, just for x equal to 1. But let's go down here. It's actually graphed here, okay? So so this is actually, so here, and I think it's a good idea to graph this, right? There's x squared minus 2x, right? Here's your tangent line. And you can just see it just grazes, right? It just grazes the parabola at the point 3, 3. And so you might want to just try that same